Hello man cavers, welcome back. Today we're going to be working on a little part from my work. I have a motor flange, and this motor flange is off of a, well, I don't want to say off of, was designed to fit a 450 horsepower vertical motor, and it drives a 4-stage vertical lift pump at the station that I work at. And the issue that we had was we purchased a new pump. It came in. We had purchased a new motor because our stuff is pretty old and the motor's been rebuilt several times. Pumps have issues, so we purchased a new pump and new motor. Anyway, went to put the new motor on, and the flanges that they had made for the new motor, because the pump was slightly different, it was a different manufacturer than the pumps that we had been running in the past. The new motor we got has the standard size shaft on it, which is 2 5/8 roughly. But there's a step on that shaft, and when they had this flange made to mate to the motor, which it should have worked, if we were using an original motor, it would have worked fine. As a matter of fact, they actually had 2 of these flanges made because they were having such issues to get it. And truth be known, we've already put the old motor back on because we couldn't get the flanges to go on the new motor because there's a step in the shaft. And what I'll do is we'll break in here just a second, and I'll take you to Fusion 360 and I'll show you what I've got. I modeled it up in Fusion 360 so we could figure out what we need to do, but we need to machine a step in this flange that will allow this to slide up far enough, because in the bottom of this there's a receiver groove. On the shaft, you'll be able to see it. There's 2 half-moon keys, if you want to call them that, locks that go on the shaft. Then this actually drops down and secures those so this can't move down any further, and it drives off the shaft. It actually drives off a 5/8 keyway that's on the shaft. There's no set screws or anything around this, and then this flange bolts up to the one that goes on the pump. So all that being said, we're going to go to the lathe, we're going to set this up, we're going to machine the groove in it. And I say a receiver groove, a clearance groove, to get this up on the shaft far enough, because it likes about a 3/8 of an inch of getting up far enough to get these locks in. So anyway, we'll cut over to Fusion 360 real quick. I'll show you on there so pictures, can explain it a little bit better than probably what I just fumbled through right now. And then we'll go to the lathe and I will try to machine this sucker out, because I think it's been hardened, but I don't know how hard. And we'll find out. Anyway.
All right, so what we're going to do is we're going to model this up. I've already done all the hard work of dimensions and all that stuff, so I'm going to go through it step by step with you, maybe a little bit quick, but if you got any questions, feel free to drop some comments down below and we'll go over that. But the first thing I did was started a new project and named my whole project, and then I wanted 2 components that I knew for sure. So you can come in here, you can click new component, and then select my 2 components and name them. So the first one I want is my motor shaft. That's what we're going to start with. So I start on my base origin. I get my shaft size drawn out, finish that sketch, and then I extrude that sketch. So this is the very end of the shaft. That's where the coupler is actually going to ride. And then we come up and we make a new sketch, and let me make sure I got these on so we can see them. This is the diameter of the shaft where the actual lip and stuff resides, where we have the clearance issue. So once we get that, I extruded that. Now we have those 2. Now we're going to do another sketch, and this sketch here on the bottom is going to cover our keyway. And what I did for the keyway measurement to figure out exactly where this needed to go was I took a measurement off of this face to the base of this keyway with my micrometer and got that distance, and that told us how deep this keyway is in the shaft. So I got that, and then this arc here, if you want to call it an arc, is the receiver groove for the C-clips that go down here at the base. And what I do that now is I will actually extrude out this keyway. So there's your keyway. It's just a simple extrude function. And then the next extrude that we're going to do is this one here, and I'll break it down a little bit closer. So what I did here was an offset extrude. And if you're not quite familiar with that, what that does is allow you, when you come in and click offset, and it allows you to select the face you want to offset from. So I knew my dimension from here to here is 8 millimeters. So I've got offset extrude. My offset, I want to start at 8 millimeters. I know my width of my groove here is 10 millimeters. My depth of my groove is already determined by my inner circle there. And I just set it to cut. And boom, voila, our shaft is done. So let me turn these sketches back off so we can see it. So now we actually have the shaft. So the next thing we want to model now is the actual motor flange. So I started it off of my shaft here. I want to start my drawing there, but I don't want it to be that shaft. But since I started everything in the center, we should be pretty daggone close. So we could actually turn that one off. We want to start our new sketch. So I was able to get my dimensions here for my width and stuff to make sure all that looked right for the keyway. So that's what we're talking about right now is the keyway. And I knew what my measurement was, my clearance all the way to this edge here, and that's how I got my keyway depth. So once I had the keyway depth and my inside circle of the actual flange, which included the clearance that's needed to clear the shaft, I was able to put that in. This circle here represents the step on the bottom of the flange. Our receiver for the keeper, if we represents the thickness of these keys, these two half-moon keys that go into those slots. And then this is the outer diameter of the main body. This is not where the bolt holes and stuff actually go in, but outer diameter of the main body. So the next thing we want to do is start extruding. So I'm able to just come in here off of our measurement, off of our dimensions here, and I just extrude this and this. I click on both, turn on blue, extrude them out to the dimension that our actual part is. And then I can come in and do another sketch, which is the base circle where the bolts go in. And we can extrude that. And then we will do the next little extrude, which is the receiver groove where the half-moon keys go, retaining keys. All right, after we do that, then we do our next sketch. Let's turn the shaft back off. So I just put the bolt hole flanges in just to give it a little bit more realistic view, but let's say we come here. That's my bolt hole diameters. So let's go back to this one. I've got to finish my sketch out. Finish, come back to that one. So this is the overall diameter of the other one, which is 7 inches. Finish this one. So this was in the original sketch. So we can look at our dimensions of all. And we're good. Now we'll extrude those through. Then we do the next groove, which would be this one on the top. Extrude it down. So, you see this was the one from down there. This is the new one here that gets that clearance. Does that make sense? I hope it makes sense. If it doesn't make sense and you got questions, leave a comment and I'll answer it back. But I think you can see what we're looking at here. Now we've got all this turned on. So everything's good, everything's happy. So we've got relationships here, which is this joint there. Whenever I made all this, I actually drew it all out down here on the bottom so I could do this joint in a way that would be somewhat realistic to the way we want the coupler to slide on. In order to get this depth that I needed here, and to show you what the issue was, if we slide this up till it's top of it's basically at that lip, so we did not have the clearance to get these keepers in. That's why I needed to machine this receiver in there, or clearance ring, or whatever you want to call it. And once it slides all the way up, it goes to a cross section real quick. To inspect, we want to do a section analysis, and we will pick any one of these. Let's pick that one. Now you can see there when this thing slides up, that's the clearance we want to allow us to have clearance to slide these keepers in. And truth be known, when I go to machine it, I'll probably go just a little bit deeper just to be on the safe side, but I think we'll be okay. But this is the cool thing about learning to use the software, so that you can come back in and even model up parts that's already been done or been done by other people to see if you're going to have any clearance issues or where your problems are going to be at, that kind of thing. But this allows us to look at it. There we go. How about that? Save. And we can do some drawings if we need to, so we can get our reference numbers and that kind of deal for when we go to machine it and double check everything. So that's what we can do with 3D modeling software, even if you're not using it to design stuff. So there you go. That's what we end up with. So let's go get on the lathe and do some cutting.
All right, so I got everything set up. What we want to do is we need to open this up to step on the flange is 2/700, so we want to open it up just a little bit more than that. This is measuring on 2/6/300, so we want to go at least 70 thousandths, probably 100 thousandths to make sure we got the right clearance. And my depth I need is 325 thousandths, so I need 3/8 of an inch roughly to be able to get it where it'll slide up far enough. So we're going to touch off on our face, set my dial indicator, and then I'll touch off on the inside, and then we'll start making cuts and see how this goes. That step there still kind of worries me, but we're going to see figure out what speed we need and go from there. There we go. Start there. I may need a little more speed than that, but let's touch off and get our zeros set. And I did indicate this in, by the way, and I'm within a tenth, 100. So I'll go there. I'll set my dial, my hand dial on 0 plus my dial indicator. I want it on 0 also. Set it in a good spot. I'm gonna run it in. I'm gonna move it to my 325 and reset my 0. Then that way I know when I reach my 0 on my indicator, that's where I want to be. 100, 200, 300, 25. On my indicator, I'll be just past 4, come back to my 0, and I'll be happy. All right, now I need to touch off on the inside. Probably gonna have to speed this thing up a little more. This is a carbide insert, so it should be okay. All right, so I'm there. Set my hand dial on 0, and since this is working backwards, it can get a little tricky. I'm gonna set up another dial indicator on my cross slide so I can watch all my measurements, but you know, we only need to come out 100 thousandths, so I mean, we should be good. We'll just stop and take extra measurements. I'm gonna speed this up a little bit. Put my guard down. Just gonna start off on about 2 thou, and let's see how this likes it. There's some hard stuff, and I'm getting a lot of chatter. Alrighty. Only taking 10 thousandths passes. I'll try a 20. Let's see what a 20 does. I'm scared it's gonna get too aggressive with that interrupted cut. You can definitely hear it now. I think I like the idea of 10 thousandths each. Take more passes, but I don't think we're going to have the issues. Let's get a measurement on it here. We are at 2/700, so we are right at the shaft size. We only need to go a little bit more. I may just go another 20, 25 thousandths and try that on the and see how that works. We don't need very much clearance. We just need enough for this thing to slide up past, and it's not going to take much. So we're at our 2/700 now. So let's go up a little more. Open it up a little more anyway. Well, let's check our measurement. Well, let's see where we're at. Starting to clean up nice now. Yep. 2/720 is where I'm at. 2/715, 2/720. So let's take another 10 off of it, and I'm gonna go 2 steps of 5. We'll clean it up. Another 5. Let's check her now. So we're at 2/735. Let's go 2/750. That'll get us 25 thousandths of clearance on each side of it, or 50 thousandths total. So we need to go another, what did I say, 235, so we need to go another 15. We need to take another 15 thousandths off of it. And I'm not showing 10 on my, oh, that's right. I'll only show half the distance on my indicator. Got to remember that. If you got your indicator on here, you're only going to show half your distance. So I'm showing 2.5 now, which is right. And we'll take another, that should put us where we want to be. That should give us enough clearance, but I may just open this thing up just a little bit more, just to be on the safe side for, this is a clearance fit. This is not something that's going to be riding on. We just want to make sure this has got clearance over that step in that shaft. All right, I think that's going to be plenty of clearance. So we'll chamfer our sharp edges, and I think we'll be good to go. Hit this outside edge, put a little chamfer on it, and I think we'll be golden. Actually, I'm just gonna hit it with the cross slide. And there we go. I think that'll work. It's a win. We got it done. All right, so anyway, here's what the finished product looks like. We got this step here machined in, and so hopefully this thing will slide all the way up on that shaft now. And like I explained in the Fusion 360 portion of this, the motor and stuff that this thing slides on, it was not the pump manufacturer's fault. It was not the motor manufacturer's fault. Not really. Things are designed differently, but they made 2 of these flanges because they were scared they wouldn't get one in time. And the other flange is actually on the old motor that is on the new pump, but we want to put the new motor on the new pump. So I opted to machine this in so we can make that happen. So pump manufacturer, the vendor who we got it from, has been great about fixing all that stuff and everything. But anyway, this goes to show you that with a few tools, yeah, everybody doesn't have a lathe in their shop, but you can pick these things up pretty reasonable. I have seen several of them for sale around here lately that are pretty inexpensive. You don't need one as big as what I got. Again, that and my milling machine came from my fabrication shop I had before. So that's why they're a little bit bigger, industrial type stuff, but you don't have to have that. And as I just showed you, you don't have to have digital readouts and all that stuff to make things like this happen either. So that's another plus. But anyhow, thanks for watching. Give me some feedback in the comments down there also. I have recorded this whole thing on the Action 5 Pro, the DJM cameras. I just got this thing a few weeks ago and decided, hey, let's try this whole video with it. And so let me know what you think of the quality of the video. Give me a little bit of feedback, maybe some settings I could change on it to make things better. I don't know, because I've never used one of these. You know, I've had a couple of the little cheap like Action ones, but those things sucked. So anyhow, let me know what you think of this video quality. If it's subpar, I'll go back to the other camera, just use this for close up underneath stuff, like just did on the lathe, that kind of deal. Or if it's working out well, I may just go to recording much more of it with this camera. So give me some feedback, subscribe, comment, because you hear everybody say it. That kind of stuff does go a long way to helping the channels. And hopefully it does, because our channel needs some help. A lot. Anyway, thanks for watching. Y'all have a blessed day.